Hello, everybody. Yigit, do you want to introduce yourself and to start your screen share then? I let you go ahead.
All right, let me put up my screen first. Okay, I was sharing just fine. Okay, I think it's finally, it kept throwing errors saying the screen share has stopped, but I think we're good now. Hello, everyone. My name is Yigit Karanfil. I am the Director of Technology and an Associate at InStudio. And today's presentation will be about making data-driven decisions for selecting hardware in AEC. So do I just move on with the presentation then? Or I guess we move forward. Okay. Okay, so I'm going to start with, oops, this is acting up. Sorry about that. So yeah, a bit about myself. I am a architecture graduate and a technology enthusiast. Most of my work has been in design technology. In the past, in like mid to large size companies. And at InStudio, I'm managing both IT and DT side of things. So the skills that are relevant to this presentation is like I'm basically an expert in design technology, and I've been doing a lot of IT management, automation, and data analysis in the last few years. So here's an outline of the presentation, what we're going to talk about today. So I'm going to start with why I use data analysis for making decisions. So this is something I do quite a bit, not just in the kind of hardware scope, but in general, I like using data. So I'm going to talk a bit about that. I'm going to explain what RFO benchmark is and how do we customize it and how did I use it for my purposes in this case. And then I'm going to move on to how I process the data using Power BI and the conclusions that I came away with from this whole endeavor. So yeah, I'm going to start with why I collect data. And the reason I would use data is I find that gaining objective metrics really helps you eliminate bias, both from your audience and sometimes yourself, actually. So you will see in this presentation that I personally had some assumptions and biases that were that I had to kind of come over with some hard data. And it's generally a great method to engage the executives, your leaders, like your decision makers in the company, right? If you provide them the data, if you show them the graphs, the numbers, you can make a much more convincing argument, and it's a very effective way of communicating. And in general, in a consulting business like architecture or engineering, time is money. Like any effectiveness, like anything that increases your efficiency in the company is going to result in you being more profitable or more competitive. So you can basically determine a return on investment, basically. So if you're trying to make a point about hardware, then you can show, okay, what does the new hardware give us? And you can put a dollar value on obtaining new hardware or like refreshing your hardware. And it's a generally good way to get support for your own projects and the goals behind them. Okay, sorry. Let's move on to the next slide. And the way I collect the data in this exercise is, well, first of all, depending on your discipline or what your company does, you might need different data. So we're going to focus on RFO and Revit today, but it's because that's the application that we use the most, and that's the one that has the most impact, right? It's much easier for a computer to maybe run AutoCAD. Maybe we don't need benchmarks on that. If a computer is able to handle Revit, it will most likely be able to handle AutoCAD just fine. But if you're doing more renderings, for instance, maybe you want to actually measure how Unreal Engine runs on your computers, maybe how Twinmotion runs on your computers. So you got to determine first, like, what software do you use the most, and maybe talk to your team about what is their most time-consuming tasks, like what are their challenges. Just talking to your team, like going to the team members, the designers, to understand their challenges could help you a lot in means of what you need to measure. And at that point, you know what to measure. You basically need objective metrics of performance, like what's the time spent on certain tasks, maybe. And again, for this presentation, we're looking at RFO benchmark. So let's talk a bit about RFO benchmark, what it is, and what it does. So RFO benchmark is a free tool. It's developed by Gordon Price. It can be downloaded at Revit Forum website. It can be a bit challenging actually to find it. Because it's not really posted on any sort of like GitHub sort of space. As far as I can see, you really need to go to just Revit Forum and just download the file from links there. And what it does is it imitates the activities of a user, such as opening a file, creating certain things, maybe copying things, rotating views. So there's a whole bunch of tasks that it does, and it does them in an automated manner using a journal file, actually, and it measures the time it takes. So it takes away the human factor, and it's all like about how long does your machine take to do the same exact task. So you have a pretty good measure of like apples to apples comparison between your devices. And one of the nice things about it is it's customizable. You're actually able to customize a lot of things regarding how it runs things. And it uses a PowerShell script and some XML configurations, which I've both edited, and I've given some tips for like what to look for and how to edit them in this presentation. But yeah, it actually just comes in as a zip file like this. The screenshot you see here, this is the application, right? There's no installation really. So yeah, I mean, the setup is you just unzip the file, and I really recommend reading the manual. The TXT file, the README TXT, is really, really useful in understanding what you need to do and how it could benefit you. Like you can nail down the customization pretty well to serve your exact needs, actually. So don't just take my word or like copy what I've done. Like preferably you would build your own customized configurations that work for you. Maybe there's different things you're measuring. I'd really, really recommend doing that. And one of the nice things is it can run from a network location, and it can also save the results to a network location. And there is no Revit knowledge needed to run it, actually. So you could actually configure the entire thing and ask it to drop all the results to a network location, and have your IT technician just run through like a few computers and just run the benchmark on them. All they need to do is just double click a PowerShell script, and it's going to go off on its own. Again, no Revit knowledge needed, so anyone can run this once it's configured. So first part of the customization, the most important thing I think that I've done here is edit the XML file to copy the results, or move the results rather, to a network location that we have. So basically I could read off all my results from the same exact folder afterwards. So there's just a line item. So I'm using the Visual Studio Code here, but you can use any XML editor. You can even use Notepad. It's just going to be very difficult to edit because there's not going to be any color coding. But you're also able to actually create your own tests here. So you can see, for instance, there is like full simplified or full expanded tests. So you can indicate every single task your custom set will run. I opted for using the full standard task and collect all the data and then filter it afterwards. I figured it's better to just have the data and I can sift through what I need and what I don't need afterwards. So, but again, it's really up to your preference how you want to run this. The other piece of customization I've done is adding these flags to the PowerShell shortcut, right? So I've numbered the flags at the end of the kind of shortcut here. So the first one basically determines what test it will run, right? So if you have a custom test, you have to actually edit this to reflect what test you're running. So you need to type in the name of the test you indicated in the XML file. So you get here by right-clicking to the PowerShell shortcut and then just adding these flags at the end of the target, basically. And then the second piece here is the run, how many times you're going to run this. So I opted to run it 3 times. It seemed like a good number. You can do more, of course, but it's going to take more time as you increase this amount. The nice thing about that is like usually there shouldn't be too much variance between the runs, but there will be some, right? It's just never always like perfectly the same exact time. So running it a few times and getting the average is a good idea. And the last one is the CSV flag, which I highly recommend adding. So the default output is a TXT file. And if you add the -CSV, it will do both TXT and CSV. And I'm going to show actually why I recommend that. So TXT result is really nice actually. So if you open a TXT file, it's a very human readable file. And it will actually tell you the averages of the numbers. So for each task, it will indicate to you how much time it took to run that task. But it will tell you how much time it took to run the task, but it will only give you the average. The CSV file, on the other hand, is a more machine-readable format. So it's a comma-separated value. So each run is indicated as a separate column there. And they're all separated by commas, as CSV clues you in. And at the end, you see what task it ran. So this is better for processing lots of results in Power BI. If you're running maybe 2-3 machines and kind of want to see, just want to physically look at it yourself, TXT is better, but CSV is better data, essentially. Now, so basically we customized our file and just double-clicked on this PowerShell script on a whole bunch of computers. What that gives us is a whole bunch of data in a single place, right? Now we need to start analyzing this. So I'm not going to go through every single step, but you can basically, again, do what works for you. But I'm going to give some tips for how to process this data in Power BI. This is not going to be like a step-by-step Power BI session. And also, I wanted to indicate that you can pull the data in the same way using Power Query in Excel, right? So if you just want to use Excel, you can do that too. You will follow pretty much the same steps, but I would highly recommend Power BI. It's just so much easier to process data in there, in my opinion. Let's move on. Okay. So basically, because we already configured our XML to put all the CSV files into one spot, we can just indicate a folder as a data source in Power BI and just point it to that folder, and it's just going to pull everything in that folder. So that's quite easy. And it's going to look something like this, right? So the first column, let's go back. So the first column here is where it says binary. It is where the content is actually. All the CSV data is there. And the second column is the name of the file. And that's actually going to help you get the name of the computer because they are all in the same exact format. It's going to tell you the Revit version, the test run it actually executed, date, and then the computer name. And I recommend just pulling the computer name from the file name. So you can parse this using the, if you parse it to take the part of the text after on, it's going to give you the computer name, right? Because this is actually nowhere else. Like you can't pull this data from anywhere else. But the file name is good enough. It will give you the computer name. And then if you really want to, you can associate that data with, if you have hardware information coming from somewhere like Intune or TeamViewer, you can actually associate that with a relational database. We didn't go that far in this case. I knew what each computer was like more or less, and we were going through other organizational things, so it wasn't really necessary. I wanted to compare the older computers to newer computers. And the third column is going to be like your extension. So again, you can use the file name for this, but essentially you just want to eliminate all the TXTs because they have the same exact data in the CSV. It's just, again, harder to process. It should be possible if you really try, but it's going to be much more difficult to process that in Power BI. So you can just filter out the TXTs. And once we just filter out the TXTs and kind of expand the CSV data to columns, it's going to look something like this. So it will repeat the computer name on each column. You will have 3 columns that indicate each run. Well, in my case, I did 3 runs, so I have 3 columns. If you did more runs, you will have more columns. And it's important to keep it consistent. So if you did 5 runs for some computers and 3 runs for others, it's going to be a lot more complicated. So try to keep it like very consistent. So this is much easier on you down the road. And at this point, basically, I decided to eliminate some things from my sets. You can do this later when you are building the charts as well. I just chose to do it here. It's like just a matter of preference. And the things I've eliminated are, I actually highlighted them, you can see on the screen. So there's things like exporting all views as PNG or printing everything as raster. Like these things are not very typical for a user to do. They're going to, the data coming from these tasks is not going to be valuable. And render, for instance, right? Like who does their renders in Revit these days, right? I really haven't seen anyone do that in the last maybe 5 years, maybe more. Especially when tools like Twinmotion are free. You really shouldn't be running renders in Revit, and I chose to just ignore this stat. And of course, after we process all this, we were just going to process all that data, and we're going to get averages of of the results for each task, and we want to see the results. So what I built here is a chart like this. So this was pretty much the only chart I built. You can really dive deeper. Again, it's possible to associate the data using relational databases and compare things like, okay, how does the 8th gen processors comparing towards 11th gen processors, like things like that. We didn't go that far. We just, again, wanted to get a general picture of what's happening. And what you're seeing essentially here is there's the computer name on the x-axis. You see each computer's name, and you see the sum of the time spent basically for the benchmark. So I averaged everything out. So I averaged everything out and then added up the time it took to complete the benchmark basically for each computer. Which means if the number is lower, the computer is performing better because they're doing the exact same thing in a less amount of time. And the values you see here are in seconds. So if a column says 325, it means it took 325 seconds to run the tasks. So an interesting thing that Kyle, our IT specialist, brought up was there is a setting in Windows which apparently becomes a bit of a problem, especially if you upgrade from Windows 10 to Windows 11. So the IT housekeeping was not amazing before I joined. We're doing much better now. We've been we've been improving how our systems work, like keeping them up to date, like much better in the last few years. But what we noticed is there is a setting in Windows 11 that's called GPU scheduling. And if this setting is off, Revit just simply does not use your GPU, right? So what you're seeing in this chart actually is the benchmark run on the same exact computer, right? But one of them, in one of the benchmarks, we had the setting on, right? And that just gave us 17% free improvement. So that's quite a bit for just flipping a switch on your computer. So yeah, this was one of the last lessons learned. So I would say, please do check that button and turn it on. It's, if you don't, you're leaving performance on the table. And then the most important thing we wanted to see was actually how do the older desktops are performing versus the newer laptops we're buying, right? So we were purchasing some devices. Like some people had actually Microsoft Surface tablets assigned to them, which were really not performing well, right? They are not machines that are geared up towards any kind of CAD work, right? So we wanted to see, like, okay, we're buying these kind of Lenovo workstation laptops now. How are they faring? And I was of the opinion that desktops would still hold up pretty well. Even like the 5-6-year-old desktops would hold up well against them because they're desktops and they have better cooling. They tend to be more upgradable. They still had decent amount of RAM, but I was totally wrong actually. So this is this is what you're seeing in the chart here, So compared to our median desktop PC, basically, this is not all the computers, by the way, in the company, but we basically picked a good variety of like different generations of devices. And on the left end of the chart, you can see definitely like things that need to be retired. But we found that our median desktop PC actually performed worse than the lightweight workstations, right? Which is assigned for occasional kind of Revit use in InStudio, which is actually the device I'm using right now. So the one you see marked up on the right side. And yeah, this actually performs 33% faster than the median desktop PC. So I was surprised to see that, but also happy to see that. And of course, when we compare the median desktop PC to our newest mobile workstations, so these are kind of bulkier, like 15, 16-inch machines that are purpose-built for this kind of workload. They were 98% faster. That's almost double the performance. So that was helpful in making a clear case for like, yes, first of all, we need to upgrade our devices. And then second, like laptops can actually perform really, really well compared to desktops that are a few years old. So this actually helped me make the case to move more of our users to laptops, because not only they were performing as well, they were actually performing much, much better. And the newer the devices, the better it performs. Actually, the generational improvements, I was underestimating the generational improvements, it seems. And I guess I want to talk a bit about conclusions. I did talk a bit as I went through the charts, but I want to kind of summarize like what our findings were. So I went through all this data collection, customized files, ran these scripts on each computer, and like, was it worth? I guess like, was it worth really going through all this effort? And I think yes, it was definitely worth, and I've learned quite a bit from this exercise. I think I managed to defeat some of my own biases and my assumptions. Like, so the objective data helped me learn something. And as I said, even the lightweight workstations actually perform considerably better than our desktops. And the data like clearly demonstrated that we needed to refresh hardware, right? Because the new devices we bought were severely outperforming the older ones. And we also learned that the new processor technology is, and like we also see much higher core counts on processors these days, which Revit is not great at utilizing in general, but the clock speeds are also rising as well. And that combination seems like creates an objective, creates an objectively better performing device. And at the end of the day, I was able to present this data to partners and just added some laptop purchases to our budget and move more staff to mobile devices. So we're still going through this transition. We're almost done actually assigning laptops now, but this study basically kicked off the whole process. So suffice to say, I'm pretty happy with the results and how this helped me communicate to leadership to justify some decisions on my end. And that concludes this session. Thank you very much for attending, and I think we'll take any questions. If there's any questions, I think Florian's gonna curate them.
Sorry, I think my microphone was off, really. Can you hear me?
Yes.
Okay, so sorry. Thank you so much for your presentation. There is a question from Hassan. I'm wondering if you already answered it. Could you further elaborate on the rendering software you use instead of Revit and the benefits?
Okay. So I guess the remark I made about Revit rendering is because honestly, Revit rendering was always terrible. Like, it was never good. Honestly, like, it was okay to use if you had nothing else. But literally just bringing your model to anything else would get you better results, right? So we've seen the development of V-Ray for Revit, for instance. If you want photorealistic results, maybe that's a good option. But otherwise, I generally go with game engine solutions such as Enscape or Twinmotion. They are a lot faster to create renders in volumes. It's a lot more instant feedback, and you're able to mitigate any mistakes much easier as well. So if you made a mistake on V-Ray and spent 3 hours rendering an image, and you realize, oh, okay, there's something we need to fix, then you need to spend another 3 hours just rendering that, right? But with game engine solutions, you're able to get almost like snapshots, basically, that are very, very quick to generate. And their quality is amazing, honestly, like compared to what we had like maybe 10, 15 years ago.
Okay, great. Hassan, if you have other questions or comments, feel free to add in the live chat so that Yigit can further develop. I had a question also for you, Yigit. I was wondering how much time it takes from the moment you thought of this project to the moment you really reach your conclusions and were able to, to say, okay, that was a great one.
Oh. So that's a bit complicated. So part of the problem is we had too many moving parts, like different things were happening. We were upgrading some components maybe on the computers and such, right? But I would say if we made this the priority and, ran at a more kind of steady pace, it shouldn't take you more than a couple days to kind of nail down what your customized, like your customized benchmark will look like, right? So you would basically try to build a set and indicate the locations and try running it on one computer. And once you do that, like you can run through like hundreds of computers essentially in a very short time. So for us, like let's say like 35 to 40 users, I think we would have got this done in like maybe 2 weeks, and that's and that 2 week time frame is mostly to accommodate users, right? Because when I'm running a benchmark, I don't want anything else running on the computer. So the lunch break is a great time to do these. So ask people to just kind of shut down everything maybe. And we just double click the PowerShell file and we know that there's nothing else hindering the performance and it's more apples to apples.
Okay.
Yeah.
Okay. Great.
But if you're like, if you want to collect every single metric for a 1,000 people company, for instance, like that will take more time. But also I could argue that that's not very necessary because you want to standardize your devices. And, if you have standardized devices, maybe taking the metric from maybe 3-4 devices is probably enough. Like you shouldn't need to run it on every single one.
Okay. At least to test and Okay, great. And how big is your company, by the way? So InStudio.
We're about 35 people now. It's been kind of fluctuating, but we're I guess considered mid-size for in the interior design scene.
Great. And do you think this is? I mean, it depends on the size of the companies, but what you were explaining to us during this presentation, how does it apply to, bigger or smaller companies? I mean, how can we adjust?
I think there is value in this exercise for every company because at the end of the day, you want to make sure that you're buying the right devices for your users that's going to perform the best for them, right? And again, if you're going through an exercise like I was, where you want to upgrade some devices, having that hard data really helps. It doesn't have to be as convoluted as like, for instance, like for me, the easiest part was processing this in Power BI because I'm pretty used to it. I use it all the time, right? Sometimes on maybe unnecessary things, but anyways, I'm using it to find a daycare for my child right now. So that kind of thing. So you don't need to go as overkill, but you can still, maybe pull numbers from like 4 or 5 computers and just use those numbers as your, you can just literally have the time elapsed on each computer, and that's a good objective metric.
Okay, great. So I see there are no other questions. So, do you have anything else to add, Yigit, before we close the session?
Not really. Thanks to everyone for attending.
Thank you for attending and have a great day. Thank you so much, Yigit, for your insights. Bye-bye.
Bye.